To solve the equation 3 raised to power x plus 9 raised to power x equals to 27 raised to power x, the first thing we should do is to express 9 and 27 as powers of 3, so that we have 3 raised to power x plus 9 is 3 squared, then raised to power x, and 27 is 3 cubed raised to power x. Then this becomes 3 raised to power x plus 3 raised to power 2 raised to power x becomes 3 raised to power 2x, and on the right hand side of the equation we have 3 raised to power 3x. Then we can make a transformation of variables by letting 3 raised to power x be y, so that the equation becomes y plus 3 raised to power 2x becomes y squared, and on the right hand side 3 raised to power 3x is y raised to power 3. Then subtracting y and y squared from both sides, on the left hand side we have 0, 0 equals to y raised to power 3 minus y raised to power 2 minus y, which we can also write as y raised to power 3 minus y squared minus y equals to 0. Y can be factored out, so we have y times y squared minus y minus 1 equals to 0. Applying the zero product property, it's either y is 0 or y squared minus y minus 1 equals to 0. So we have the first solution for the variable we transform into, y equals to 0. Then we need to look for the other two solutions from this quadratic equation. And to do that, we are going to first find the discriminant in order to know the nature of its roots. So considering y squared minus y minus 1 equals to 0, and comparing with the general form of a quadratic equation, the coefficient of the y squared is 1, so a is 1, coefficient of the y is minus 1, that b is minus 1, and the constant term is minus 1 as well. Then the discriminant d is b squared minus 4ac. So the discriminant is minus 1 squared minus 4 times 1 times minus 1, which means that the discriminant d is 1 minus 4 times 1 times minus 1 is plus 4, that is 5. The discriminant is 5, which means that the roots of the quadratic equation are real. We can then proceed to using the quadratic formula to find the roots. The quadratic formula is y equals to minus b plus or minus the square root of b squared minus 4ac, which is the discriminant, over 2a. Substituting the values of the discriminant b and a, we have y to be minus 1 plus or minus the square root of 5 over 2 times 1, and that gives y to be 1 plus or minus the square root of 5 over 2. With this, we have found the remaining roots of the cubic equation we had when we transformed the variable from x to y. So we can say now that the values of y are 0 or 1 minus root 5 over 2, or y is 1 plus root 5 over 2. Then we start putting these values into the transformation we made in order to get the corresponding values of x. Recall that we have transformed from 3 raised to power x to y. So if 3 raised to power x is y, then it means that x is going to be the logarithm of y to base 3 by definition. Now we start putting the values of y one after the other into this equation to get x. So the first case is when y is 0. When y is 0, we have x to be the log of 0 to base 3, which does not exist. So that means at y equals to 0, x has no solution. The second situation is when y is 1 minus root 5 over 2. Now, a look at this shows that when we find the square root of 2, it's actually greater than 2. And that is going to give us a negative value for y. And the log of a negative number, logarithm of negative numbers do not exist. We can say x equals to the logarithm to the base of 3 of 1 minus root 5 over 2 has no real solution. The solution is not real because the logarithm of negative numbers are not real. The third scenario is the case when y is 1 plus root 5 over 2. Substituting means x is going to be the logarithm of 1 plus root 5 over 2 to the base of 3. And this is the only real solution to the equation. So we can conclude by saying the only real solution of the equation 3 raised to the power x plus 9 raised to the power x equals to 27 raised to the power x is x equals to the logarithm of 1 plus the square root of 5 over 2 to base 3. Now we believe you have enjoyed this tutorial. It's an Olympiad question. Don't forget to leave your comments and questions in the comment box. You can also help us grow by liking, sharing the video, and subscribing to this channel. Thank you and see you next time. Bye.